Is the third and final part of the lecture notes here. If you wanted to check your answers to the example questions, they are right here. For number 1, you should get 2.7 grams per milliliter as the density. For number 2, you should get 50 milliliters. Number 3, you should get 231.84 grams, and I showed my work in red. And then finally, for question 4, we compare the density of 2.7 to the table. That is aluminum. So this must be aluminum if it has the same exact density. All right, let's talk about drawing and particle diagrams. So here are two particle diagrams. Let's say we'll make a circle equal to 1 gram. And let's say the box is equal to 1 milliliter. We could look at both of these things and say this is more dense, this is less dense, or it has a higher density, and this other one has a lower density. If we wanted to do a sample calculation with that, this looks like it is 5 grams in 1 milliliter. That would be its density. This one looks like it's 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This looks like it's 15 grams in 1 milliliter. So this one definitely is more dense. What does that mean, more dense? More dense means in the same space or volume, there is more mass. Looks like the particles are more compact. Or closer together. Whereas less dense is the opposite. What does less dense mean? Less dense means there's less mass in a given volume. I'm going to write this in a different color, or the opposite. For the more dense here, there is more mass than volume. For the less dense, there's going to be more volume than mass in general. And so, looking at some density examples here, we have something with a low density and something with a high density. You can see it's very compact. This is kind of like a solid, whereas this low density tends to be like liquids or gases. These two objects are equal in volume. How do they know they're equal in volume? Same size box, but different in mass due to their density. So you could clearly see that this high density one, it kind of falls or sinks. Things that tend to have higher densities will sink. So higher densities tend to sink. I'm going to call that sink. Right? So they're more massive. And please make a note that your less dense things are typically liquids or gases, and your more compact, higher density substances are solids. So let's look at this random example here. We have density of cork. It says it's less than the wood, and it's less than the metal here. So if the density of water is 1 gram per milliliter here, and we know that, which of these objects will have the highest density? The cork, the wood, or the metal? Well, whichever one sinks the most will have the highest density. So we could clearly see between these three, the cork is floating. The wood is kind of floating. It's not sinking. And then the metal is completely sunk. This has the highest density. It probably has more mass in a given volume. So I would go with the metal. All right, let's look at comparing density graphs here. And mine's color-coded. Yours might not be. You might need to add this in. But we have three graphs here. We have aluminum right here, which its slope would be y equals 2.7x. We have water, which we know water is y equals 1x. And then we have ethanol, which is a different type of liquid. Ethanol, its slope would be y equals 0.789x. So let's change our language. Which substance line has the greatest density? Don't forget that density is the slope. How can you tell? Whichever one's going to be the highest. So looking at our graphs here, I could clearly see the aluminum is the most dense. So I'm going to say aluminum. It's the highest up. If the middle graph is that of water, which substance will sink in water? Which substance will float? Well, it will sink if it has a higher density, aka higher graph. And it will float if it has a lower density or lower graph. So I could look at this graph and I could say that the aluminum, that's going to sink. It's got a higher density. But the ethanol, that will float. And if you had to explain, you would say it has a higher density. Same thing for the ethanol. The opposite, it would float because it has a lower density than water. Couple more before we're done. Let's say we were not given the densities of these substances. How can we calculate the density of aluminum from the graph? This is great for a future quiz or test question. If I needed to calculate the density, we could estimate, we could say slope. Again, don't forget slope is pretty much y over x. It's like y2 over y2 minus y1 over x2 minus x1. We could say it's approximately y over x. Don't forget that is density is mass over volume. That's the same thing. So let's look at aluminum here. Let's choose a data point. Let's look at this data point. For 10 milliliters of aluminum, which is an X value, this is about 27, I promise you. The mass is about 27 grams of aluminum. That's the Y value. This number is about 27. So if I wanted to get the slope, it would be Y divided by X. Slope will be Y over X. We could do 27 over 10, 2.7 grams per milliliter. This is like a nice little trick. Like if I wasn't given the data, if I can't see it, I could estimate and just do a Y over X. It's a nice little quick trick to calculate slope, approximately. If you wanted to, you could do y2 minus y1 over x2 minus x1. There's going to be a very important data point here, 0, 0. At 0 milliliters, there will always be 0 grams. Always. So if you wanted to, we could do 27 minus 0 divided by 10 minus 0. I get the same answer. So it's a nice little trick. Slope is approximately y divided by x, or mass divided by volume for us. Which of these substances would have the greater mass in a given volume? So now, this is where, just like in our previous notes, I'll zoom back here, this is where we want to choose a volume, draw a vertical line. So I'm going to go back now. Choose a volume. Let's choose 10 and draw a vertical line. We could clearly see that aluminum is the highest up. So it has the most mass in a given volume, in a given 10 milliliters of volume, whereas ethanol has the least mass. So I would say aluminum, and I drew a vertical line. This last one, and you'll see this on a future power standard, it says which of these substances would have a greater volume in a given mass. Now I'm going to do draw a horizontal line. And whichever one is the farthest to the right, kind of the opposite, like furthest up. So I'm going to draw a horizontal line. Let's say I will draw maybe right here. Doesn't matter. All right, I hit aluminum. Then I hit water. Then finally, I hit ethanol. This is about, I don't know, making that about 10 grams. It looks like I get the farthest volume for ethanol, which is about 16, 17 milliliters. Whereas water would be about 10 grams. And aluminum would be a lot less than that. Aluminum would be about 3 to 4 milliliters. So for a given mass, the farthest, which for us is ethanol, has the largest volume. So ethanol would be our answer. It is the farthest right if I draw a horizontal line.